Hello everyone and welcome in this new recording. Today we will just go quickly through a few updates that I have just introduced in the NervForge project, and that should be actually a pretty small recording because we don't have much to discuss. But yeah, anyway, let's get started now. We have the default tree display here, and the first thing I have changed is how we can manipulate the length scale. If you've seen the previous recording, the first one, before this length scale was a global parameter, we could say. It was not defined per level, but I think it actually makes sense to be able to define this length per level so that you can have different length value. For instance, for the level 1, here you could see that, yeah, this is a pretty long one and those are pretty small, so maybe this one you could reduce a bit the length of it, yeah, like that. And for the level 2 instead, you will try to increase this to make the branches longer compared to the initial radius of the branch. So yeah, you can now control this length setting per level. So that's for the first feature that I have modified. So the next one is on the density of the branches. So let's say we increase a bit the number of level 2 branches, but first let's display also the other levels, and we go with level 1 and you increase child density here. So you have a lot of branches, obviously, and they are pretty well distributed along the tree, maybe a bit too well. So in some cases, I guess you might want to introduce some randomness into this. So I have for that now on the pruning tab this prune density factor, also defined per level. Actually, you can try to modify that for the level 1, but the meaning of this is if you reduce this value from 1, it means that for each branch that you're going to generate at that level, you will have a random check. So if you put that to 0.5, for instance, there would be one chance on 2 that the branch you're considering will be discarded. So here we're only generating one root branch. So if you put that to something else than 1, we have a chance to see the tree completely disappear, like here. And if you change the seed, in some cases you will have a branch, in some cases you would have nothing, like here again. So probably not a good idea to modify that for the level 1. We'll set that to 1 again. But then for the level 2, then it could make sense. If you want to reduce a bit the number of branches in a random way, then you can reduce this and you will get just a few branches popping here and there randomly. So I guess that could help to make the tree look a bit more realistic again. So as I said, again, you can modify that per level. And okay, so this is it for the second feature. The third feature that we have now is this checkbox here, and it's actually going with the export button, and now we have support to export the tree in binary GLTF, so as a GLB file, which is going to make the file slightly smaller, I guess. And this is just enabled by default because I don't think there is any point in exporting the non-binary version by default. I mean, yeah, you can still uncheck that if you want to export the GLTF anyway. So we can just give this a try maybe. Let's just add a few more branches to the tree just for the fun. Level 2, we're going to increase that, get more level 3. And here also more level 4. And for the leaves, let's just use the only real leaf that we have, and increase the size of this. More leaves. Okay, and I guess that could be a good tree. So let's try to export that. And we're just going to use the same name again, tree GLB. I save this. And now, just like the last time, we can just take this tree model file and we can use this GLTF viewer and drag and drop it here. And you see that it's still working properly. There's no error reported and the tree is displaying fine. And yeah, this is it for the feature that I have added on the NervForge Tree Generator itself. But then I thought that maybe I should mention that in fact, this project here is built with two separated projects. So we have the NervLand project itself, which is the main one, providing all the elements for the web GPU display and advanced stuff. But in fact, I started to extract some base components and put all of them in this NervSDK project. And this NervSDK is currently open source, so you can access that if you go on this GitHub repository. So we have all the sources here, and you should be able, in fact, even to build this project, except that it might be a bit complicated because this is using the NervForge mechanism, so I probably need to provide some additional description on this if someone is interested in building this from sources. But anyway, what I wanted to say is that the GLTF classes are actually part of this open source framework. So if you go in the sources NVK, you have this dedicated GLTF folder, and here I have in fact implemented my own mechanism to read or write GLTF files. Actually, at first I was using CGLTF, and I'm still using CGLTF for other parts in the NervLand project itself. I guess if I search for CGLTF, I will find something in the loader, for instance, and GLTF model. This one is definitely using, yeah, CGLTF. But that's a pretty old implementation, and I wanted to do all of this differently now for this new iteration, because even if this library is working just fine, it's very efficient and everything, you probably want to use that by default. I find it a bit too well, tricky to use, and I just wanted to give it a try on my side. So yeah, here we have the result of this, and instead of providing a single file, I have separated everything in different classes like this, with the main entry point being this asset class. So that's going to provide you with the GLTF asset, which is defined here. And starting from that, you can actually read a file or write a file. So of course, there's not a lot of documentation on how you actually should use those classes, but I thought it was a pretty interesting experiment to try to rebuild that on my own, and the result is, I think, a bit easier to use. So here we have, for instance, a unit test describing how you would write a simple box as a GLTF file, and we can just quickly go through this. I'm going to create this asset object, and you can specify what is a generator, what is your copyright, and then we define the vertex format that we have, and we prepare the vertices that we want to use to render the box, and the indices also. And next you start with adding a buffer with the proper size. You can give it a name, but that's not mandatory actually. Then you retrieve the data pointer and you just copy the vertices and indices into this data. So this buffer that you just added is going to be part at least of the GLTF file. So this is something that you have ready, and in fact you could, just after adding this buffer, you could already try to write this asset object to a file and the buffer data would be written in the file. But of course you don't want to stop here because the buffer is just the first part of it. Once you have a buffer, you need to define buffer views. So we're going to add here one buffer view using this buffer, and the offset into this buffer would be 0 and the size will be the vertex byte, and that's going to be the vertex buffer view for us. And you need to specify the type of this buffer. That's part of the specification that you have for GLTF. And speaking of specification, instead you want to start from the very beginning. This is probably the first page that you should start reading. That's going to give you everything concerning the definition on the GLTF format. So I've been using that pretty often actually during the implementation, because there you can go, for instance, on the buffer and it's going to tell you what are the members that you should find in the file itself, and whether those members are required or optional, and what should be the type and everything. So yeah, this is very handy to write your GL loader or writer appropriately. Anyway, once you have your buffer views ready, you can provide accessors on top of those buffer views. So I have a dedicated function, in fact, inside the buffer view here to add the accessor directly using this buffer view. And then you can tell that, okay, to access the position data, you're going to use this accessor, so it's a vec3 with a float component. You have this number of position, and the offset that you should start at would be this one. It's going to be 0 here because that's the first member of the vertex. Then you have the normal accessor, so you define it a similar way with a different small offset in your vertex, and the UV accessor. And you also actually need another accessor for the indices itself, so you're going to use the index buffer in this case. Once you have those, you start building your mesh. So you add a simple mesh. I'm going to give it a name here, but as I said, names are actually not really mandatory apparently when you write the GLTF data, but yeah, it's not going to hurt anyway. And whenever you create a new mesh, you actually need to specify one or more primitive inside that mesh. So that's how you actually get something to render, to display. So you had one primitive here and you specify that you're going to use this indexed accessor for the indices of the primitive. And then you also specify what are the attributes that you want to have for this primitive. In this case, we're using 3 different attributes: position, the normal, and the texture coordinate, using those 3 accessors that we defined just above. And after that, it's pretty easy. You actually just, well, create a simple node to put your mesh inside, and you create a simple scene to put the node as a root node in that scene. And in fact, I think this part here is optional, but yeah, I'm not quite sure. Maybe it's better to just define a default scene, because otherwise you might not get the GLTF file to display something by default. So yeah, you just added one scene, so you just specify that this is a default scene. And then you just write this file, and that's going to give you your box1 GLTF result. Just giving you a quick look at what this file would look like. It's a regular JSON file, and you have the accessor available here, the asset subobject, the buffer views, and the buffer itself, which contains the data encoded with a base 64. And then you have the meshes, so we only have one mesh in there, the nodes, and the scene, and that's it. So pretty easy. And so if you wanted to give it a try, you could just try to use this NervSDK library and check those GLTF classes in there. Okay, so I guess this is it for this time, guys. I didn't change much in the actual visuals that you currently have here, but yeah, it takes a bit of time to change those settings, so I'm going slowly on this, and I thought it would be good to document that step by step anyway. So as usual, if you have any question, just let me know in the comments, and otherwise I'll see you next time when I get another update on this tool. So thanks for watching and see you next time. Bye bye.